Welcome to Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. With that in mind, every week we introduce you to a scientist working in the field of materials and nanoscience. Hi everyone, today we have with us Jewell, who is an associate professor at the University of Wisconsin, Eau Claire. Hi Matthew, welcome to Real Scientist Nano.
Hi, thank you so much for having me.
We are very excited to speak with you. Let's begin with understanding your research. Could you explain your research in super simple words to us?
Sure. So my research is in superconducting materials. So I work on these materials that can conduct electricity at very low temperature without any electrical resistance. And the main application for superconductors is magnets. Because they can carry electricity without resistance, they're really useful for making very high current electromagnets that can produce enormously large magnetic fields. A lot of the systems we work on produce magnetic fields in the 12 to 15 or even 20 Tesla range. And as a unit of magnetic field strength, a Tesla is already very large. A 1 Tesla magnet could pick up a small car, for example. So these systems we're building at 12, 15, and 20 Tesla are really extreme magnetic fields, and they're used for applications like particle accelerators, nuclear fusion reactors, NMR machines, things like that. But I actually don't work on the devices. I work on the superconducting materials themselves. So I look at the electrical and especially the mechanical properties of the superconductors to ask how can we build a wire or build a conductor that's going to be an effective way of carrying the supercurrent in the final device.
Okay. Wow, that sounds interesting, and I think I understood most of it. All right. What can the followers expect in the week that you will be curating the Twitter account?
Yeah, so when I've got the Twitter account, I'll try and do a couple things with it. One, I will introduce myself, of course, talk a little bit about my background, but a couple things I really want to highlight. I want to show how the materials engineering that we do at the nanoscale really propagates up and informs how some of these very large machines, particle accelerators, fusion reactors that are hundreds or thousands of tons of material in size, how really the properties at the nanoscale dictate a lot of how that machine gets built. So it's really an interesting materials problem of scaling up the material properties from the nano through the micro scale and all the way up to the macro scale, and making sure that everything works together and that it's an integrated design. So I think there's some interesting stories there that we can tell. And then of course I'll try and highlight a little bit of what we do in my lab in particular, some of the particular material systems we work with, and some of the questions that we try and answer and understand here.
Okay. All right, that sounds fantastic and well thought through, and it's a nice mixture of what a researcher does, so it's wonderful. Well, Matthew, we are looking forward to your time on Twitter. Thank you very much for speaking to us.
Yeah, thanks. I'm really looking forward to it.
Thank you for listening. To know more about us, please visit our website, realscientistsnano.org, and follow us on Twitter at realsci_nano.